Now I need you to flip your notes packet over and go to the class notes for drawing branched chain alkanes, okay, drawing structural formulas, and we're going to take some notes for these. Now there's only 2 steps for this. It's a little more intuitive, a little easier. The first step is to draw the parent chain. Draw the parent chain. So if you remember in the naming process, the parent chain was the last thing that we named every time. Okay? The last thing that we named. It's the base of the molecule. You want to draw that before you start drawing branches because you wouldn't have anything to attach those branches to if you didn't draw that parent chain. So we're going to kind of draw these backwards. We're starting at the end of the name and drawing that first. Then add the branches. Add the branches where they belong. Add the branches where they belong. So pretty straightforward. Here's the example that we're going to work with for this one. Okay, here's the name. 2, 2, 4 trimethyl hexane. 2, 2, 4 trimethyl hexane. And again, you can draw this with any of those structural formulas that I showed you in the previous video, but you want to start with your parent chain. Parent chain is hexane. Hex is 6 carbons. Ane is single bonds. So that is just 6 carbons in a row. So most students choose that carbon skeleton. Okay, 6 carbons in a row. Then 2, 2, and 4 are the locations of our branches. So I could go to carbon number 2 and carbon number 2 again because I have 2 branches off of carbon number 2, and then carbon number 4 has a branch. You could do that from the other end as well, carbon 2, carbon 4. Just pick an end and start from there. Trimethyl. Well, what does tri mean? We know tri means there's 3. 3 of this branch on this molecule. Okay, and it's 3 total. It's not 3 of them on each of these carbons. It's 3 total in the whole molecule. Meth means 1 carbon. Okay, 1 carbon. And YL means branch. So trimethyl is just 3 branches that are a single carbon each. And so my 3 branches are just a single carbon each. And that is a satisfactory structure. Just remember, if you leave it this way, and the very next question I ask you is how many hydrogens are there, you're going to have to go back and think about it. Okay, this one would have 3 to complete its 4 bonds. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So that would have 20 hydrogens that you have to know that those are there to fully understand what we're trying to teach you. Okay. A lot of students ask me, how would I do this with a skeleton structure? So let me just show that to you in case you want to use it. I think personally it is the easiest. Hexane, again, starting with that parent chain, when you put your pencil down, that's 1 carbon. 2, 3, 4, 5, 6. So that is 6 carbons right there. To double check, 1, 2, 3, 4, 5, 6. You can count those points, including the ends. Now the branches are at carbons 2 and 4. So here I have 1 branch. That's easy. Just draw a straight line up away from that peak. Okay, but here I have 2. We don't draw one in this space. This is supposed to be that 109-degree angle that carbon makes so nicely in its tetrahedrals. Okay, so if we have 2 more branches, one of them really would be sticking out towards us and one would be sticking into the paper, but on paper we're just going to draw it like that. Okay, so if you drew one down here, I wouldn't count off for it, but it just isn't thinking about the geometry of the actual molecule. So I've got 2 branches coming off of carbon number 2, 1 branch coming off of carbon number 4, and there's the skeleton structure for this molecule.